So, let us start off with this tuple relational calculus. This is a new way of expressing queries. So, in relational data model, we have so far seen a way of expressing queries using relational algebra. Now, I am going to talk about a different way of expressing queries, and this is called tuple relational calculus. Broadly, we can think about query specification in two different ways. One is what is called a procedural way of expressing the query. The other one is called the declarative way of specifying the query. Okay. I have mentioned these two things earlier also in a little bit broader, more abstract kind of terms. Now is the time to kind of make it more concrete and exactly see what do you mean by procedural and what do you mean by declarative. Those of you who have done paradigms of programming course, you know what is procedural imperative programming languages and what are functional programming languages, right. So, in imperative programming languages, they are more like procedural, they give step by step what to do, whereas in declarative style of languages like functional languages, you try to basically specify how things I mean it's the style of computing is more towards declaring what we want rather than telling exactly how to obtain what we want. Okay. So, let us leave the programming languages issue apart. As far as the query languages, a similar kind of thing is happening here. So, here in the procedural query languages, the query specification involves giving a step by step process of obtaining the query result. And the example we have seen actually is this relational algebra example. We have seen that we have to give the step by step procedure in some sense. When you give temporary relations, it is in some kind of a step before you do the final query, and you can think about these intermediate results as various steps to carry out the. So, we basically have to tell as to what are the relations to start off, and then what operators to apply, and then get intermediate results, and then proceed from those intermediate results and what other operators to apply, and so on. You build the query. So, and of course, this requires a detailed knowledge of all the operators involved, and it can be seen that it is not that easy for kind of non experts, basically people who have not studied relational systems in depth. Now, as against this, we have a style which is similar to declarative programming. So, query specification here in some sense involves just giving the logical conditions that the results are supposed to satisfy, as against telling how to obtain them, right. And this is, as you can we will see with examples and other things, is somewhat easier for use by non experts, and the tuple relational calculus is one approach of giving a declarative query language. And we will later on see that this is actually the the inspiration behind the definition of the definition of the query portion of SQL. Okay. Oh, okay. Now, before we go on to details about this tuple relational calculus, I want you to take back a little in the timeline to your probably second semester course. You studied discrete mathematics in the first year or something like that, where we have studied predicate logic. We have studied predicate logic, right. So, what exactly is a predicate? This has connection. So, we basically are the reason I am taking you back there is that we basically make use of predicates now in order to formulate our queries, and I will show you, we will argue it out as to how predicates come into the picture. So, first let us try to understand what exactly is a predicate. Somebody wants to answer the question, what is a predicate? Predicate, your propositions versus predicates, right? Propositional calculus or propositional logic and predicate logic or predicate calculus. That these are the two things that you have studied as part of the mathematical logic in discrete mathematics course, right? And even if you can't define the predicate, I am sure you can recall some examples of predicates. Somebody wants to say some example predicate? Or is it too long back that you don't remember what examples you have used in that course? Well, try, nothing wrong in, just give it a try. What is a predicate? Okay, what is the distinguishing feature that exists in a predicate and that does not exist in a proposition? Huh? Sorry? Quantifier, okay. Quantifiers, okay, quantifiers exist in predicate logic, whereas they do not exist in propositional, that is correct, yeah. But what do quantifiers do? I mean, the quantifiers have associated with them something, right? What is that something? Variables, right? Quantified variables, they are quantified variables in predicate logic. Okay, so where are these variables in first place? What kind of variables are you talking about? Where are those variables? Obviously, since we are talking about propositional logics doesn't have quantifiers and doesn't have variables, predicate logic has them. So, the variables must be in the predicates, obviously, right? Predicates is the thing that, so predicates have variables basically. Okay, so let me present the definition then. It is basically kind of an expression with some kind of placeholders. You can call them as variables, and if you substitute values for those placeholders, they hold the place. So, you put a variable there, then the whole expression assumes a truth value, it gets a truth value, it becomes true or false, Boolean value, right. That is the predicate, that is what predicates are about. And then of course, quantifiers come because we want to express some complex statement involving predicates, that is why quantifiers come, right. Even without the quantifiers, the predicate has certain meaning even without the quantifiers. Okay, let us try to give some examples. So, here is a predicate called less than. So, x and y are the two placeholders or the variables, and then if you substitute numerical numbers there, then it assumes truth value. So, if you say, so the meaning I have associated with this predicate is that x is less than y, strictly less than y. So, now you substitute 2 and 5 there, it becomes true, and if you substitute 5 and 1, it becomes false. So, it is a predicate, it takes values Here is another set of predicates. I can think of this lives in as a predicate with two variables P and C, P standing for a person, C standing for a city. Let us bring in some kind of domains for those variables. So P is a person, C is a city, and then you can see that Sindhu lives in Hyderabad is true, as Priyanka living in Hyderabad is clearly not true, right. So you can begin to see that we can do these things look like somewhat tuples in our right. So one can have n place predicates also. This is just two place predicates, then you can imagine n place predicate also, and when variables are substituted with values, then they will get this truth. So the predicates will have truth values. So let us see now what is the relation between these predicates and the relations that we have been talking about in the relational data model. So the question here is that can we interpret our relation names, can we interpret our relation names of our relational model as predicates. So let us recall what is DB relation. It is a finite set of tuples, and this tuple is a sequence of values, each value is corresponds to some attribute, right, because the finite DB relation has a schema which is a sequence of attribute names, and so these sequence of values correspond to those attributes, and so we have, and each attribute comes from the value comes from a domain which is a atomic values. So can we think of each of these DB relation with n attributes as an n place predicate? Okay. So here we make one very interesting and important assumption while interpreting DB relations like this. This is called CWA, closed world assumption. We make a closed world assumption. So in this closed world assumption, we imagine that the tuples in the relation instance. So if we have a database, then we will have a finite instance for it, right. The set of all tuples in all those relations that we have is the instance. So for the tuples in each of these relation instances, those values, if you substitute for the corresponding predicate, then that predicate assumes value true, and if you substitute anything which is not there in any of these instances, then the predicate is false. So that way we can now start correlating our relation instances as some kind of definitions for our predicates under this very important assumption called the closed world assumption. So anything which is not present in the instance, if you substitute any of those values for these predicate placeholders, the variables, okay, then the predicate is false. So this is important assumption we will make. Once we make this assumption, it can be, we can interpret these DB relations. Of course, we can even otherwise also we can interpret DB relations, but we make this important assumption called this closed world assumption, so that it can things can work out well for us. So under this assumption, as I said, the tuples in the relation instance, if you substitute the whole tuple as it is for the sequence of values in the predicate, then the predicate assumes truth value true, otherwise it is false. Okay. Now with this we will be able to use mathematical logic, in particular predicate logic, in order to express the conditions that the the result of the query is supposed to satisfy, and that becomes the specification of the query. Okay. So, how exactly it is going to be computed, we will not specify. We will specify the logical condition that is to be satisfied by the result by making use of the predicate logic statements. So, that is the approach we will take in tuple relational calculus. So, now we will see the exact details about this. Okay, is that clear as to the relations? Of course, as against this closed world assumption, there is something called open world assumption, and this open world assumption is something which we will not deal with in this course, but while we are talking about semantic verb and ontologies, we typically make open world assumption. Okay, we will come to that in a later course. Okay, so let us now talk about this declarative query language called tuple relational calculus. So, we will introduce called, so for the entire bunch of variables together, we will now introduce a kind of a big variable. So, we will call this a tuple variable. Okay, it is convenient for us to think of the whole tuples being assigned to variables rather than individual things being assigned to. So, we will call tuple variable. A tuple variable is usually associated with a relation called the range relation. We will see why exactly it is called range relation a little later. So, this variable is slightly different from the variables that I have mentioned in the previous slides. This takes entire tuples as its values. Okay. So, if T is a tuple variable ranging over a relation R with some scheme ABC, then in order to talk about those individual values, we will use our familiar dot notation, and T dot A stands for the value of the attribute A in the tuple variable, in the tuple T, okay. So, tuple is there and it has components. So, T dot A stands for the first value, T dot B stands for the second value, T dot C stands for the third value. Okay. Instead of having variables for individual values of these ABC, now we have a variable for the entire tuple, and then called in order to refer to the individual components, we will use the dot notation. T dot A equals the individual value under this in the sequence of values. Okay. So, that is the concept of tuple variable. Okay. Then the basic form of the tuple relational calculus query is simple. So, it basically has a bunch of these tuple variables, and from each of these tuple variables we are going to pick up a value to be reported as a result. Okay, that is what is being given here, and we put a vertical bar and give a condition. Okay. This theta is the query condition. This is actually the crucial part of the whole query. This is a predicate logic expression, or a statement condition basically involving these tuple variables. Okay. All these tuple variables T1, T2, Tm and Tm plus 1 through Ts, some more tuple variables could be used, whereas what is there in the this we will call as the left hand side portion of for the vertical bar. So, to the left of the vertical bar, to the right of the vertical bar is the predicate logic expression. Okay. So, these one T1, T2, Tm would be the free variables in the logic expression. So, what is not quantified is a free variable. If some variable is quantified, then we will call it as a bound variable, right. So, the free variables are the ones that can be used on are used on the left hand side, and then some components of those tuple variables will be projected in some sense as a result of this thing of the query. We will see examples and this aspect will become clear. So, basically this theta is going to be a predicate logic expression which specifies the condition to be satisfied by the result. So, I will give you examples so that this point becomes clear to you now. Let us start with some examples. The best way to learn about TRC is to work with examples only. So, let us recall our familiar schema. The student has roll number, name, all this variable, various attributes, and then department, department ID, name, HOD, phone. So, let us say obtain the roll number, name of all girl students in the maths department. Okay. The department ID is 2, this is also given. So, we do not have to find out what is maths department, the department ID is 2. So, where is this information? This information is very much here in the student relation itself, because the maths department is department 2. So, the conditions that have to be satisfied by the tuples that are required here is basically that this attribute value should be some specific value f, and this attribute value should be 2, that is all right. So, we can express that using this new notation. Okay. So, we take up a variable, tuple variable s, okay, and then say that the tuple variable should be first a student, okay, should correspond to student, and then s dot sex should be f. Okay. So, that means we are now checking the tuples specific component value, and s dot department number equals 2. So, these two conditions have to be satisfied by the tuple s. If that is the case, then since the query requires roll number and name of girl students, so we use that tuple variable and then ask for roll number and name on the left hand side of the vertical bar. So, attributes required in the result are given in the left hand side of the bar, and the condition, the predicate that has to be true is given as the condition to be satisfied to the right side of the vertical bar. Now, this particular predicate student s, as per our assumption, the closed world assumption, is true whenever this s is a actual one instance of our student relation. For all other assignments, you can imagine how this query is going to be actually interpreted. Okay. So, what we will do is we will consider all possible assignments to this tuple variable s. Okay. And for those tuple values, okay, the values are tuples here. So, for those values that are there inside the database instance student, the student s will be true. That is what our assumption, the predicate student. When is the predicate student true? If you assign one of those tuples as the value for the variable, it is true, otherwise it is false. So, it is true for that, and then in addition the tuple has to satisfy these two other conditions. If it satisfies, then make use of that particular current assignment for the tuple variable and pick up these values called roll number and name. That is what the query, this is how the query will be interpreted. Is that clear? Right? That is how the query will be interpreted. Look at all possible assignments for the variable, and those assignments that satisfy all these conditions will be used in order to project, you can even call it project actually, project the attributes of interest from those tuples. Okay. So, in general this T, if T is a tuple variable with a range relation R, then R of T is taken as a predicate, which is true if and only if the value of the T is a value in the instance R. Read this again. If and only if the value of T is a tuple in the instance R. Of course, these things when they are true is clear, right. When the left hand side is equal to the right hand side, it is true, otherwise it is false. About only this we have to clearly say when it is true, right. So, this is how in general we will interpret this predicate. Now let us first we have to understand as to what are the various things that we can do on the right hand side in order to. So, this is this is where we use the full predicate logic actually. So, we will write that. What is the general form of this condition in this tuple relational calculus queries? So, the general form is like this. The atomic expressions are these expressions, these are the atomic expressions, that R of t, where R is a relation name. Okay. Okay, here I am calling it as instance, but it is actually name, right. So, R t is a tuple variable. So, R of t is one kind of a form, the atomic form of the formula that we can use on the right hand side. The other components is T1 dot AI. So, if T1 is a tuple variable, dot AI will talk about the AI component of the tuple variable, tuple T1, and that is compared to some other tuple, and the usual comparison operators, the less than, equal to, greater than equal to are used, and then you can basically compare two values of two tuples and use that as a basic condition. And then you also can take one component of a particular tuple and compare it with an appropriate constant, okay. And these are the basic conditions. So, when are these true? We have already kind of indicated as to when these things are true. So, this is true, we have whenever t is assigned one of the instance from that particular relation, and these are obviously can be figured out as whether they are true or false by doing this comparison check, etc. This also can be figured out as to when it is true or false. So, these are the basic or atomic kind of conditions. Now, once we have these atomic conditions, we can use all the logical operators and then combine them to get complex conditions. So, the composite expressions are, I do not know whether you are familiar with this is called the inductive definitions. We are calling it, we know that it is called the inductive definition of the composite expressions. So, any of these basic atomic expressions is also a composite expression, and then if F1 and F2 are expressions, then F1 and F2, F1 or F2 and negation of F1, they are all expressions. And then here comes the quantified forms. So, for all t f and there exists t f, where f is an expression and t is a tuple variable, these are also composite expressions. And now we can, you can see that we can combine atomic as well as quantified expressions and the logical operators to get complex conditions. Okay. So, these are very familiar to us because we have studied this kind of thing in predicate logic. Basically, only the atomic things are specific to the relational algebra kind of setting. Otherwise, this is what you have studied as part of predicate logic. Okay. So, I strongly advise you to kind of revise your predicate logic notes from discrete mathematics and read up that books, and then relook at all those exercises that you have done as to how to take a statement and express it in relational predicate logic, and practice those things again, because they will be very, very useful for us now when you are expressing queries using this. Okay. So, in this once we talk about these logic formulas, we have studied in predicate logic. So, as to what is a free variable and what is a bound variable, and in this case of course, we have tuple variables. So, we have free tuple variables and free and bound tuple variables. A variable informally it can be thought of as a variable that is not quantified is a free tuple variable, where the one which is quantified is a bound variable. Okay. So, if you have any doubt about what is free, what is bound, please refer to your discrete mathematics predicate logic portion. And also these tuple variables are to certain extent, you can use the same variable name in two different parts of the expression and they will be independent, right. That is what in logic formulas, when you use an expression, use a variable x in some part here, there exists x on, and then put a scope there, and put somewhere else there exists x and put some other expression, these two things are different, right. You know that. So, recall all that, and there are what are called scope rules. So, use the braces and other various brackets carefully in order to indicate what is the sub formula that is quantified by a particular variable, etc., or quantified applicable for a quantifier, etc. Okay. So, now let us use all this repertoire or these tools in order to actually solve our problems. Our problem is now how to use all this to express relational queries, okay, relational database queries. Now, before we proceed, let me emphasize this interpretation of the query in the tuple relational calculus. So, the query will have two portions to it. The right hand side is the logical formula or the condition, right. The left hand side to the bar is the specific set of variables that are supposed to be given in the result, okay. And there are free variables and bound variables basically, okay, and lots of other tuple variables. Okay. Now, the interpretation of the TRC query is like this, and interestingly you will see that when you study SQL, it is exactly the same interpretation that gets carried over to the SQL. Okay. So, we will discuss that in detail when we come to SQL. So, okay, now all possible tuple assignments to these free variables in the query are going to be considered. Okay. There are going to be several free variables in the query. So, you consider all possible tuple assignments to them. A tuple assignment means assign certain values for the components of the tuple. Okay. And for any of these specific assignment, okay, tuple assignment, variables are there, so you have to assign values to them. So, you consider some assignment, and then for that specific assignment, if the expression to the right hand side of the vertical bar evaluates to true, okay, how do you determine whether it evaluates to true? You have the formula with you and you know how to interpret it in first order, in predicate logic, right. You know the meaning of there exists x fx, for all x fx, right. Those are standard sub formulas that are available in predicate logic, right. So, we know how to interpret each of the sub formulas, and so we will be able to compute what is when the right hand side expression evaluates to true. So, if the right hand side expression on the right hand side of the vertical bar evaluates to true, then that combination of tuple values, notice that what is the combination of tuple values here, because there are lots of free variables in a expression, you may use several free variables. So, all those free variables are to be considered together in one assignment. In one assignment we have one set of values assigned to these free tuple variables. Okay. So, that specific combination is the one that made that particular expression true in case it has made it, right. So, that particular combination would be used to produce a tuple in the result relation. How do you produce the result? So, this is how that particular combination would be used to produce a tuple in the result relation. So, while producing the result relation, basically what we do is the values of the attributes for the corresponding tuple variables as specified on the left hand side of the vertical bar would be used. Basically, this result production is something like very similar to projection. So, you have got certain tuples and their values that led to the right hand side to be true. So, in that you pick up certain specific attributes as required by the left hand side expression. Okay. So, that is how the in general the query will be interpreted. Of course, you can note observe that the only free variables are the ones that appear to the left of the. So, if a free variable does not really appear on the left hand side of the vertical bar, then there is actually no reason to use that as a free variable, all right. So, all the free variables will occur as on the left hand side. Okay. Now, let me emphasize this interpretation with the help of a query. Let us start looking at some more example queries. Okay. Now, let us again repeat the same thing. Query roll number and name of all girl students in the maths department. Now, we do not know the we do not know the department number. We know it actually, but we will act as though we do not know it, right. We will act as though we do not know the maths department number. We know that it is 2 in the data. Okay. So, obtain the roll number and name of all girl students in the maths department. Okay. So, the way this query gets expressed is like this. We have 2 tuple variables here, S and D. S is used for student, D is used for department. Okay. So, let us first focus on the right hand side of the vertical bar. So, here we are saying that if you look at this, what is the free variable here? It is given, S is a free variable, right. So, you can also see it here, S is a free variable because it is not bound with any quantifier, whereas D is a bound variable. Here we are putting there exists D and then putting a condition here. The scope of there exists D is this entire sub expression, sub formula. Okay. So, what is the formula? Student S and S dot sex is for F and there exists D such that there exists D, within that scope of the there exists D we are saying the department D and D dot name equals maths and D dot, and then you are also saying D dot department ID equals S dot department number. So, for the combination of student and department to make sense in our context where we are looking for girl students in the maths department, right, the S dot department ID should be equal to the D dot department ID where the D dot name equals maths. D dot name equals maths will be true only for the maths department tuple, right. And so, and since in some sense this is the join condition, right. We should not be using the word join here because actually that join is a relational algebra operator, but in some sense we can see that the join of S and D, okay, makes sense in our context if S D dot department equals S dot department and then D dot name equals maths. Okay. So now you can see that, so now let us interpret it as though, according to the the previous slide. So all possible assignments for the variables s and d will be considered now. Okay. Now then what the formula is saying is that, okay, you let for obviously all those tuples that are not in the student S, in the student instance, this part is going to be false. So we can limit our consideration for the tuples that are there in the student relation, the data. So then we are checking whether is this a female student, and then we are checking that does there exist a D. Okay, what is that D? It should first be a department tuple. Okay. So if you consider all possible assignments to D, for those assignments that are not inside the department, this will be false. So again we have to consider the tuples that are there in the current instance of department. So in the then you further check whether D dot name equals mass, and then since the combination makes only sense if D department equals department ID is equal to S dot department number, you put that condition also. So now you can see that if this formula is satisfied with for some assignment of S and D, then that is a valid combination that can be used to produce the result. And what is the result? The result is roll number and name. We just want roll number and name from the S tuple. We don't actually require anything from the D. So this is how we formulate queries in tuple relational calculus. So this you can see is the typical, apart from the use of the student department, these special predicates, rest of it is all is like a predicate logic expression. Okay, so basically we will use existentially or universally quantified tuple variables on the right hand side to kind of specify the query conditions. Of course, we will also use the free variables, and then the attributes of these unbound variables are used on the left hand side to specify the attributes required in the results. Okay. Now this is all actually essentially what is IRC is all about. Now the rest of it is only practice. You have to practice queries and then formulate queries and then see how exactly you can formulate. So interesting thing is that all the queries that you can express using relational algebra can also be expressed using the tuple relational calculus. And what you cannot express in relational algebra, you will not be able to express in tuple relational calculus. So they are in some sense the equivalent. Okay. So with that, I encourage you to look at read up all this material that I have talked about, and then try and try some queries. You already have tutorial sheets with you. Try and you already know predicate logic. So try to express some of those queries using this new way of expressing queries. I agree that you have to kind of switch hats. You should forget about relational algebra hat and now put relational calculus hat and think differently. Okay. So please try to do that and solve some queries before in the next class, where we will discuss actually a lot more queries. Okay.